All right, let's simplify this radical expression. So in order to do that, the first thing I'm going to do is I'm going to break it up into two radical expressions. One with the coefficient 180. So the square root of 180 is multiplied by the square root of x to the 15th. Then I'm going to go through and I'm going to break that first radical up, the square root of 180, into a product of one of these perfect squares, either the square root of, let's see, 100, or the square root of, what's the next one, 81, or the square root of 64, 49, 36, 25, 16, 9, or 4. So we need one of these factors to be a factor of 180. I won't go as high as 144 because obviously 144 is too big to go evenly into 180. So let's see, do any of these work? Does 100 go into 180? No. 81? No. 64? No. 49? No. 36. 36 works. Turns out that 36 times 5 is 180. So I can break this first radical down into the square root of 36 times 5. And by doing that, I'll be able to split it up, and the square root of 36 will be rational, and the square root of 5 will be a third. I'm going to do the breaking up of the second radical now. That one is going to require a little long division, so let's go ahead and do the long division required. I'm going to divide the 15 that is the power by the 2 that is the index. Well, 2 goes into 15 7 times. 7 times 2 is 14, and 15 minus 14, the remainder is 1. So both these numbers are going to play a role in what I break down because they add up to 15. And then when I take the square root of x to the 14th, it's going to give me x to the 7th. So all those numbers will take apart. Let's see here. So we'll take the square root, and we're doing the square root here of, I'm going to break it up into x to the 14th plus 1, because that's x to the 15th. So that's x to the 14th times x to the 1. That'll be x to the 14 plus 1, which is x to the 15th, when you add the exponents. And actually, let's make the one that's not rational blue. All right, so once we have that, we're going to break it up now into, this is going to be the square root of 36 and the square root of x to the, or the square root of 5. And then this second one is going to be the square root of x to the 14th times just the square root of x. And then when we look at this, the two red ones, actually I can simplify more. The square root of 36 is 6, I know, and that square root of x to the 14th I can break into x to the 7th squared. These two, though, those two have to stay on the radicals, each one. So on the next step, I'm just going to write both of them under the same radical. So the square root of 36 I know to be 6. The square root of x to the 14th, well, I need to find a power of x that if I square it, I'll get x to the 14th. And that number is 7. You could have just divided the 14 by the 2. That number in here is 7, so x to the 7th. And then we still have, of course, the square root of 5 and the square root of x, which I'm just going to write as the square root of 5x. I'm just going to combine those radicals at this point. And then lastly, let me see. The square root and the square will cancel, but because 2 is an even index, when I do cancel those, I have to leave the absolute value of x to the 7th. So it's the absolute value of x to the 7th. And then I come back here, and this is going to be just the square root of 5x. Now the question is, can I get rid of the absolute value? And the answer is, because of the fact that 7 is an odd number, if I raise a negative number to an odd power, it's negative. But if I raise a positive number to an odd power, it's positive. And since I cannot be certain as to what the sign of x to the 7th power is, I cannot get rid of the absolute value, because the absolute value symbol treats positive numbers different than how it treats negative numbers. So if I'm not sure of the sign of x to the 7th, I have to keep it. So plugging this answer in, the answer is going to be, it was 6 absolute values of x to the 7th times the square root of 5x. So that's 6 absolute values, and once again, without the absolute value, it will be marked wrong. 6 absolute values of x to the power of 7, and then that's going to be multiplied by the square root of 5x. Square root of 5x. All right, so there you go. That's question 6. Question 7 is similar to it. Let's see if we can't work it the same way. So question 7, let's see. Question 7, simplify. And this one is 216, and it's a square root again. Oops. Yeah. 216, and it's a square root again. So I'm going to break it up. It's going to be the square root of 216 times the square root of x to the 29th power. I need a perfect square that goes into 216. On my list, the one that's going to work is the square root of 36. 36 is the largest perfect square that goes evenly into 216. So I break up the 216, and I break it up as the square root of 36 times 6. 36 multiplied by 6. The next one I'm going to break up also. I'm going to break that one up by long division. If I divide 29 into 2, well, that's going to be, let me see, 1, 1, and that, or 1, 2, I should say. That gives a 0. I bring down the 9, and then 2 goes into 9 4 times. 4 times 2 is 8. So my remainder is 1. My remainder is 1. And it looks like 28 is going to be the number I'm looking at to break this up. It's going to be x to the 28th multiplied by x to the 1st. And I was making these ones that can be simplified red. So the x to the 28th is going to be able to come out 28. So now I'm going to break this up now. The first one is the square root of 36 is there, and the second one is going to have a square root of x to the 28th. Those are going to be the ones that I can actually simplify. The ones I can't are the square root of 6 and the square root of x. Square root of 36 is straightforward. That's just 6. But I still have the square root of 6 tagging along. And the square root of x to the 28th I can rewrite as whatever power of x I need to square to get 28. That's going to be squared. And the answer is going to be 14, just like the 14 we got here. And that's times the square root of x. So here we have it now. We just have to simplify this. So I'm going to move all the things that I can actually simplify, or that I have simplified, to the front, these red things. And this is x to the 14th squared. And this is the square root of 6 and the square root of x. And then, finally now, the square root of x to the 14th squared, the square and the square root cancel, leaving the absolute value of x to the 14th. That's still multiplied by 6. And I'm going to put both of those surds under the same radical, the square root of 6x. Now, since any real number raised to an even power like 14 is always positive, it means I know that x to the 14th is positive. And because I know x to the 14th is positive, I can get rid of the absolute value. But only because I know that an even power of x is always positive if x is a real number. So that's going to be the answer I'm going to plug in. It's going to be 6x to the 14th without absolute values, square roots of 6x. So make sure you don't use the absolute values there. All right, so that's numbers 6 and 7. Here's number 8. Simplify this radical. We're doing the same thing now, except this one is a cube root. Whenever it's a cube root, you don't have to worry about absolute values at all. So this is going to be the cube root of 16 times the cube root of x to the 8th. Now, once again, perfect cubes, for instance, the cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. And obviously these numbers are too big. So I'm looking for one of these perfect cubes that's a factor of 16. The only one that makes any sense at all is 8. So I look at breaking this up into the cube root of 8 times 2. Cube root of 8 multiplied by 2. And then that second one, I'm going to do long division. Once again, I'm dividing 8 by 3. That's going to be 2. 2 times 3 is 6. So that's going to be 2 with a remainder of 2. Don't forget, these two are the numbers we add together to get 8. So those are the powers of x I'm going to break it up into. And this one is going to be the power of the actual answer, of the x on the outside of the actual answer. So I'm breaking this up then into the cube root, it's a bit large, into the cube root of x to the 6 times x squared, because 6 plus 2 is 8. And I was making these red here, the factor that simplifies x to the 6. So then I break it up. It's going to be the cube root of 8. I'm going to bring that one out. I also have that cube root of x to the 6, which I know I'm going to be able to simplify. And then the ones that I can't simplify are the cube root of 2, this one here, and the cube root of x squared, this one here. So the cube root of 8, I actually know the cube root of 8 is 2. We said that already. And then the cube root of x to the 6, I'm going to break down. I'm going to find a power of x that if I cube it, if I raise it to the 3rd power, it'll give me x to the 6. That power of x has to be x squared. So x squared here. And then this is multiplied by, I'm just going to put these two together as the cube root of 2x squared. And then finally now, I have the 2, and I have the cube root of x squared cubed. The cube root and the cube power cancel, leaving x squared. But because the index is odd, I don't need to worry about absolute values at all. And this is going to give me the cube root of 2x squared. And this is going to be the answer. This is going to be the answer. So that's 8. And one last one here. So we have here that this is the 4th root now. So once again, since this is even, since this index is even, we are going to have to worry about absolute values. So I'm breaking it down first into 2 parts. One of them is going to be the 4th root of 48. The other one is going to be the 4th root of x to the 50th. So I'm looking for 48. I'm looking for a 4th power that goes into 48. So I'm thinking the 4th powers. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is 2. And then 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So the 4th root of 81 is 3. And I already realized that the only possible number that can go in there that's a 4th power is 16, other than 1, of course. 81 is too big, so 16 has to be the number. I'm going to break this up into the 4th root of 16 times 3. So it's the 4th root of 16 times 3. And the other one is going to be broken up also into the 4th root. And then I'm just going to look for 2 powers of x. And in order to find those powers of x, I'm using long division once again. is going to be how many times 4 goes into the power of x 50. So let's see, 4 goes into 50. Well, it goes in there once. 1 times 4 is 4. I subtract and I get 1. And then I bring down the 0. And 4 goes into 10 twice. So 4 times 2 is 8. And I subtract and I get here, this is going to be 2 as the remainder. So I'm going to break up x to the 50th into x to the 48th times x to the second, because 48 plus 2 is 50. So I'm breaking this up into x to the 48th times x squared. Because 48 plus 2, when I multiply those together, I add the exponents, I would get x to the 50th. All right, then I can break it up then. It's going to be the 4th root of 16 times the 4th root of 3 times the 4th root of x to the 48th times the 4th root of x squared. All right, so when we simplify these, let's see, the 4th root of 16 I know to be 2. The 4th root of x to the 48th I know to be, well, I can break that one down, but I'm going to bring it out to the front here. And the 2 that I cannot simplify any further, I'm going to keep here, the 4th root of 3 and the 4th root of x squared. All right, so now that I have that, I can go through and I can actually simplify now the 4th root of x to the 48th by figuring out what power of x I have to raise to the 4th power in order to get x to the 48th. So there's a power of x that I raise to the 4th power to get x to the 48th. I could just divide 48 by 4 to get the answer. 12 is the answer there. And those 2 that I can't get out of the radical, I'm just going to put under one radical as the 4th root of 3x squared. And then here I have the 4th root of x to the 12th to the 4th. The 4th power and the 4th root cancel each other out. And this is going to be 2. And then because this is an even index, I need the absolute value of x to the 12th. And then, of course, this is going to be multiplied by the 4th root of 3x squared. Now, because of the fact that 12 is an even number, when I raise a real number to an even power, the answer is always positive. So I know for a fact that x to the 12th, since x is real, x to the 12th is positive. Since I know it's positive, it's equal to its own absolute value. So I can get rid of the absolute value, and this will be 2x to the 12th, 4th roots of 3x squared. Now, if this were a 13 or an 11, I wouldn't be able to get rid of the absolute value. And that's how we simplify radicals.